So in the last lecture on selection, I felt like at the end I gave you a coin sorter example, and I felt like maybe that wasn't crystal clear why I was talking about that. So what I said is if you get the conditions in the wrong order, it doesn't work. So I just want to expand on that a little bit. So if you imagine that you are defining some procedure to choose your clothes, right? I think that was the example we had. Choose clothes. And that procedure involves one, I guess we had to write enter the temperature, right? And then we read that into a variable called, I'm just going to call it temp because I'm lazy. And once we've done that, we had a decision to make, right? So here at line 3, we said if, and this might not be exactly what we did, but I'm going to say if the temp is greater than 90, then we print, I think they might have used the word write, but I'm going to say print, I guess, what do they say, wear short sleeves? I think maybe they just said shorts. And if else, so if, and then the matching else, if the temp is greater than, I don't know, 70, print maybe t-shirt or something, right? And I'll abbreviate it. I had more conditions, right? I think it was else if temperature, and I'm just going to skip, say greater than freezing, print jacket, wear jacket, right? And finally, else stay inside, right? And so we get this pseudocode, and I think I did a flowchart as well, and the idea is you're either going to do option A, option B. I should use a different color there, right? Option A, option B, option C, or option D. You're only going to you're going to select one of those only. And what I was trying to say is that at this point in time, when you're in option B, I know that temp must be greater than 70 because of this condition, but I actually know more about the temperature. The temperature must also be less than or equal to 90 degrees, and that's because this condition was false, right? So every single time you pass a condition, you're kind of implicitly adding to these. So at this point in time, I know that the temperature is between, so I know that 32 is less than the temperature, and that temperature must be less than or equal to, the previous one was 70. Right? Even though here it just said the temperature was greater than 32, I inherit the fact that every previous condition is false. So now if we were to kind of rewrite these conditions incorrectly, so let's imagine after 2 we come down to, I guess, version B of 3. That's a B, right? I'm just going to write 3. How about I use red for the alternate one? So the blue for the alternate one. So 3. Suppose I said if the temperature is greater than 32, print wear a jacket. Else, if the temperature is greater than 70, print t-shirt. Else, if temp greater than 90, print, what did I say, shorts, right? Else, print stay home. So we kind of have two versions of these conditions, and if we trace through, we can see that one of these is semantically wrong. Nothing is contradictory or completely wrong about these. All of these statements, you could write a program for them and it would be a real program. But one of these programs has an issue. It's called dead code, and it is an indication that the person who wrote, for instance, this condition doesn't really understand what they're doing, and there are lines of code here which will never ever be executed. And to see that, let's imagine that it's a nice, let's imagine that the temperature outside is 95 degrees. Okay, so that's a nice warm, I'm in Arizona right now, so that's a nice, it's actually much hotter than 95. What is the actual temperature today? It is a 110 degree day in Arizona. So let's imagine it's a nice 110 degree Arizona summer day. And we come here. So we look at the temperature. Is the temperature greater than 32? Yeah, right? So we're going to print wear a jacket. And then after that we skip over everything else. So according to this loop, in Arizona we're supposed to wear a jacket. Right? Now it's not only the fact that clearly you don't want to wear a jacket in Arizona. This semantically was probably supposed to be handled by this guy, wear shorts. So that's kind of A, B, C. So block should have been in block A, right? But instead we went to block C. And the reason is because the condition here says temp is greater than 32, and that worked in the previous loop because we knew from the previous condition that the temperature was also less than or equal to 70. Right? So when you're putting these loops together, if you put them in the wrong order, then you won't inherit the other condition, which is that it's cooler than 70 degrees. Now this can be fixed in a couple of ways, but let me point out to you, you will never ever hit any of this code. Because if the temperature is greater than 32, you're going to say wear a jacket. If the temperature is less than or equal to 32, then it clearly can't be greater than 70, and it clearly can't be greater than 90, so you'll never hit either one of those. If the temperature is less than or equal to 32, you'll come down here and you'll print stay home. So all of this loop will ever tell you to do is wear a jacket or stay home, and this code here is dead code. You wasted your time writing it, you wasted somebody else's time trying to read it. Of course, this can be fixed. We like to write, generally we like writing fewer bits of code. So the right way to fix it is just to organize your conditions like this. Right? But it's also possible to fix it by adding a condition here. We could say if the temperature is greater than 32, I'm going to put parentheses, I'm going to say and, so this is one condition, and we can make sure that another condition also is true, and temperature is less than or equal to 70. So now this whole bit right here becomes the condition of this loop, and it's a much more complicated condition, so we prefer simpler ones because logic can be tricky, right? So now we know that the temperature must be greater than 32 degrees, and also the temperature must be less than or equal to 70, or you won't go in here, which means if it's 110 degrees, it doesn't satisfy this condition, therefore it doesn't satisfy the overall condition, and we will jump into the else. And we'll say that it's t-shirt weather unless we fix this one as well. Okay. Clearly this is not ideal. It's better to do things like this. When it could be done like this one's better. If it could be done like this with simple conditions, and instead you do it with really complicated conditions, that's an indication that you don't understand that you can do better. And you always want to try to, just like when you first learned fractions and your teacher would say, don't say 10/3, say 3 1/3, right? This indicates, even worse, don't say 10/2, just say 5. If you in a math class, if you submitted this as your answer, your teacher probably might have marked it wrong, right? Because you didn't recognize that that's 5, which is sort of a really fundamental thing you should understand. So I'm going to wrap that up with the idea that, yeah, in selection, there's this idea that the previous conditions are false, or else you never reach that current condition.